Appliances and central air conditioners, while containing motors, typically do not fall within the 25% of the largest motors in a home. This is because these motors are generally smaller than those used for other purposes. Examples of motors commonly included in the 25% largest category are sump pumps, large attic fans, pool pumps, heating, ventilation and air conditioning blow motors, and well pump motors. Also, dishwasher motors, clothes washer motors, clothes dryer motors, and garage door opener motors can fall within that range. The specific motors included in the 25% largest category may vary depending on the size and electrical characteristics of the home. Motors in devices such as refrigerators, microwaves, and toasters are typically too small to be included. Some homes may have additional motors, such as those for ceiling fans, that could potentially fall within the 25% threshold. When considering the 25% largest motors in a home, it's important to understand the National Electrical Code requirements for sizing conductors and overcurrent protection devices. The NEC provides guidelines to ensure that electrical systems can safely handle the starting and running currents of motors. NEC Section 430 covers motors, motor circuits, and controllers. The code emphasizes the need to account for the motor's full load current, starting current, and duty cycle when determining the appropriate conductor size and overcurrent protection. Article 430.22 specifically addresses the sizing of conductors supplying a single motor. It states that the conductors must have an ampacity of not less than 125% of the motor's full load current. This requirement is to account for the fact that motors draw significantly higher current during startup than during normal operation. For example, if a motor has a full load current of 10 amps, the conductors supplying that motor must have an ampacity of at least 12.5 amps. Article 430.52 outlines the requirements for motor overcurrent protection. The type of overcurrent protection required depends on the type of motor and the application. For example, inverse time circuit breakers are commonly used for motor protection. The breaker must be sized to protect the motor from overload and short circuits, but must also allow the motor to start without tripping. The NEC provides tables and formulas to help determine the appropriate breaker size. The code also addresses the protection of motor control circuits. Motor control circuits are the circuits that control the operation of the motor, such as the start and stop function. These circuits must be protected from overcurrent and short circuits. NEC Section 430.72 provides requirements for the protection of motor control circuits. It specifies that the control circuit conductors must be protected by overcurrent devices rated or set at not more than 300% of the control circuit conductor ampacity. In residential applications, several types of motors are commonly found. These motors are used in a variety of appliances and equipment. Some pumps are used to remove water from basements or crawl spaces. They are typically powered by fractional horsepower motors. Attic fans are used to circulate air in attics and reduce heat buildup. They are typically powered by fractional horsepower motors as well. Pool pumps are used to circulate water in swimming pools. They are typically powered by larger motors ranging from 1 to 3 horsepower. Heating, ventilation, and air conditioning blower motors are used to circulate air in heating, ventilation, and air conditioning systems. They are typically powered by fractional horsepower motors or small horsepower motors. Well pumps are used to pump water from wells. They are typically powered by larger motors ranging from 1 to 5 horsepower or more. Dishwasher motors are used to circulate water in dishwashers. They are typically powered by fractional horsepower motors. Clothes washer motors are used to agitate clothes in washing machines. They are typically powered by fractional horsepower motors. Clothes dryer motors are used to tumble clothes in dryers. They are typically powered by fractional horsepower motors. Garage door opener motors are used to open and close garage doors. They are typically powered by fractional horsepower motors. The location of Pennsylvania may have unique electrical codes or requirements that supplement the NEC. Always consult with a qualified electrician to ensure that electrical work is performed in accordance with all applicable codes and regulations. In addition to the NEC requirements, it is also important to consider the voltage and current requirements of the motors when selecting conductors and overcurrent protection devices. Motors are typically rated for a specific voltage, such as 120 volts or 240 volts. The conductors and overcurrent protection devices must be rated for the same voltage as the motor. Motors also draw a specific amount of current. The conductors must be sized to carry the motor's full load current, plus any additional current required for starting. The overcurrent protection devices must be sized to protect the motor from overload and short circuits. When selecting conductors, it is important to consider the ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. Therefore, it is important to select a conductor with an ampacity that is sufficient for the motor's full load current at the expected ambient temperature. When selecting overcurrent protection devices, it is important to consider the motor's starting current. Motors draw much higher current during startup than during normal operation. The overcurrent protection devices must be able to withstand the motor's starting current without tripping. There are several types of overcurrent protection devices available, including circuit breakers, fuses, and motor overload relays. Circuit breakers are the most common type of overcurrent protection device used in residential applications. Fuses are also used in some applications. Motor overload relays are typically used in industrial applications. It is important to select the correct type of overcurrent protection device for the application. When installing motor circuits, it is important to follow all applicable codes and regulations. The conductors must be properly sized and installed. The overcurrent protection devices must be properly sized and installed. All connections must be tight and secure. It is also important to ground the motor and the motor circuit. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. When working with electrical systems, it is important to take precautions to protect yourself from electric shock. Always turn off the power before working on any electrical equipment. Use insulated tools. Wear rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electrical systems, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take precautions to protect yourself from injury. Always follow all applicable codes and regulations when working with electrical systems. Always consult with a qualified electrician if you have any questions or concerns. Remember, safety is always the top priority when working with electricity. Understanding the motor types in your home and their electrical demands is crucial for safe and efficient operation of your home's electrical system. Proper selection of wiring, overcurrent protection, and adherence to electrical codes are essential for preventing electrical hazards and ensuring the longevity of your appliances and equipment. When dealing with electrical work, it's always best to consult with a qualified electrician to ensure that everything is done correctly and safely. This is especially important when dealing with motors, which can draw significant amounts of current and pose a greater risk if not properly installed and protected. Always prioritize safety and follow all applicable codes and regulations. Additionally, consider the energy efficiency of the motors you use in your home. Energy-efficient motors can save you money on your electricity bill and reduce your environmental impact. Look for motors that are labeled with the Energy Star rating, which indicates that they meet certain energy efficiency standards. Regular maintenance of your motors can also help to improve their efficiency and extend their lifespan. Keep the motors clean and free of debris, and lubricate them as needed. If you notice any signs of wear or damage, such as unusual noises or vibrations, have the motor inspected by a qualified technician. By taking these steps, you can ensure that your motors are operating safely and efficiently, and that your home's electrical system is protected from potential hazards. Finally, remember that electrical codes and regulations can vary depending on your location. It's important to be aware of the specific requirements in your area and to follow them carefully. Your local building department can provide you with information about the electrical codes and regulations that apply to your home. They can also provide you with a list of qualified electricians in your area. When choosing an electrician, be sure to check their credentials and experience. Ask for references and check with the Better Business Bureau to see if there have been any complaints filed against them. A qualified electrician will be able to assess your home's electrical needs and recommend the best solutions for your situation. They will also be able to perform the work safely and in accordance with all applicable codes and regulations. Investing in a qualified electrician is a smart way to protect your home and your family from electrical hazards. It can also help you to save money on your electricity bill and improve the energy efficiency of your home. By taking the time to learn about the electrical systems in your home and to follow all applicable codes and regulations, you can create a safe and comfortable living environment for yourself and your family. Always remember that electricity is a powerful force that should be treated with respect. By following these guidelines, you can help to ensure that your home's electrical system is operating safely and efficiently for many years to come. Understanding the nuances of motor applications and code compliance is key to maintaining a safe and functional home electrical system. From selecting the right motor for the job to ensuring proper wiring and overcurrent protection, every step plays a crucial role in preventing electrical hazards and maximizing energy efficiency. Don't hesitate to seek professional guidance from a qualified electrician to address any specific concerns or complexities related to your home's electrical system. Their expertise can provide peace of mind and ensure that your electrical infrastructure is well maintained and up to code. By staying informed and proactive, you can create a safe and energy-efficient home environment for yourself and your loved ones. This detailed discussion emphasizes the importance of understanding the electrical demands of various motors in a home, selecting appropriate wiring and overcurrent protection, and adhering to electrical codes for safety and efficiency.